What's up guys, it's Nitin here from acentasecond, and today we will be discussing how I approach mathematics and how you should start considering it. So I usually look at math as something very abstract, almost as a second language, because it has its own definitions of everything, what it stands for, and it's easily translatable from English to math to that and back. So you can use it as a language and a form of communication in a sense. Though you fully may not be able to hold a full conversation, you know what I mean. But what I consider math and why it may be hard for you to grasp in a sense is that it's a topic that's very conceptual. You need to understand the underlying principles first, apply those principles, and then approach the question. You can't just move into a question like 5 plus 3. That's easy. We've been taught that our entire lives what 5 plus 3 is. We can pick up 5 here and 3 here, and we put them together as 8. We learned the underlying conceptual principles. We said 5 is a quantity that represents 5 of something. 3, and when you add means that you combine them together. So 5 on a number line from 0, 1, 2, 3, 4, 5, and then you add 3. Adding means you move on the right of the positive on the number line. So 5, 6, 7, 8, that's your 3. That's why you end up at 8. So a very simple conceptual concept we just broke down in multiple ways. And so you can use sticks, 5, 6, 3, 6, adding. The concept of addition is what is here. But when we get to complex subjects, such as taking derivatives and integrals and all these other concepts that people have come up with to solve their problems, well, it's exactly that. It's to solve a specific issue that someone had while they were doing mathematics. And so when you have a concept of an integral, it's finding the area under a curve because someone had a problem. They broke it down. Basically, let's say you have a football and you want to find the volume of a football. What they did is they took a shape, a parabola, and they started rotating it. Conceptually, we understand that that shape makes a football, or you can make any shape you want if you start rotating a certain line. So if you start rotating it, it will make a shape. Rotations create volume because area is 2-dimensional, and adding a 3rd dimension with the rotation, that z-axis creates that volume. And so that's when people had to start considering double and triple integrals, because you had more and more variables to consider, more parameters. And so if we understand the underlying principle of what an integral is from one point to another, the area under that curve, and how you find that area, you take that function and you integrate. So basically you add 1, or you take the antiderivative, and so the antiderivative helps you form almost like a area formula. So it tells you, okay, from here to from 0 to the last point is this much area, and from 0 to this other point is this much area. So if you subtract them, you only get the area you want. And so you take this underlying concept and just keep on applying it further and further. And so for a volume, it's just another integral because there's only one more variable, like I mentioned. And so that's why you might need a double integral, a triple integral. And in some cases, it's more and more variables you need to consider if you go in higher dimensions and different concepts. So you are using principles to solve specific questions, and that's why sometimes your approach may not be the right approach for a question, though it might work or it might not work. So that's what you need to think about. Is your approach right? If it's not right, why is it not right? Because why? So let me give you an example. You can add 2 negative numbers, right? So you can add -5 and -4, get -9. Or I can do -5 minus 4. We know that the keep, change, flip rule, or keep, change, however you learned it, those are two ways of solving the same question. You get -9 in both situations, but the way you got it was different. And that worked because the number line concept is very simple in that respect, that if you can follow these specific rules, you will get the same result. Sometimes when you get into more complex questions, it may not work out as such because there is certain caveats within the procedure that may not allow you to do so. So that's the type of approach you need to start taking, that what is this question asking me and what tools in my tool belt can I use? Because there's very limited tools that we have at our disposal in the first place. There's not a million ways to do a question, but there's only a few select ways to do it. And if we can learn those things and start applying to the different questions and start saying, oh, this is what I need to do when I have this type of question, that will start helping you solving questions down the road that are more complex. Like we know 5 plus 3, 8, perfect. We have mastered that. But when we start doing 5 times 3, that's another concept. That's repeated addition. You're adding 5 3 times, right? And so you start taking the concepts that you have made, making them more complex for your further needs. The whole reason why we do math is to solve problems and things that need solutions. We just don't come up with things that out of nowhere. Like everything starts with a question, that underlying assumption that leads to an answer. And that's what we're trying to discover. It's a whole discovery matter. And that's what's so exciting about math, that you can discover things on your own, whether it be discovered by someone else already. That's a personal journey that you can take, or something that no one else has done. Just venture down that road. Use existing concepts and just go have fun with it. And I know at the moment, a lot of you might think math is hard. Why do I need this? Trust me, math is literally everywhere. People who struggle with mathematics tend to not have a deeper understanding of things in a conceptual matter dealing with math. So whenever anything involves math, they just evade it because they never took the time to adjust and understand those principles. And just believe me that if you just take a second to learn these concepts that are very underlying theorems and principles that we have, it'll make your life so much simpler. Like the video I made about the power rule and taking derivatives, that's literally 50%, if not 80%, 50 to 80% of calculus 1. Integrals, that's basically a 3/4 of what Calc 2 is. And if you just learn those things in 5 minutes that I made the videos on, you're basically there, right? And so don't try to overcomplicate things. Try to think where things may come from, even though you may not fully understand them. Like, I don't have a full understanding of math, and that's why I go back and try to look at things where they root from, why things happen in a certain way, and start breaking down that procedure. And that's what you should do with math. You should start thinking in ways that help you solve the problem instead of making it more difficult. That's all I have for today. Thank you so much for watching. If you ever need any tutoring help, link down in the description. Peace out.